All right, so this is not the section I wanted, 7.3. So we'll So first of all, we're going to look at some keywords here. In part I, it says verify. In part II, it says prove. So what's the difference between verify and prove? How do we solve questions that are verify? How do we solve questions that say prove? Well, the setup is very much the same. When you want to verify something, what you're doing is you're checking for a specific value. In this case, theta is 30 degrees. So you set it up exactly the same way where you draw your line. So here we're going to verify theta equals 30 degrees. And what you do is you plug in 30 degrees into the left-hand side. And you plug in 30 degrees into the right-hand side. And then this becomes a pie plate question. What we need to do is work through the solutions on both sides and see if they're the same. So again, it's a little puzzle. We're trying to make the left-hand side equal to the right-hand side. What is cos of 30 degrees? Is it 1/2 or root 3 over 2? Close. Root 3 over 2. Nothing like being close in a true and false question, eh? Now, if cos of 30 degrees is root 3 over 2, then what's secant of 30 degrees? 2 over root 3. And so I can work on the left-hand side. Now, my goal here, if I work on the right-hand side, we already know that secant is 2 over root 3. So one of the reasons that we practice writing things as a single fraction at the beginning of this unit and simplifying fractions is because right now those look different. But if we have a way of simplifying things, if we have a way of writing both sides as a single fraction, then perhaps it's going to help us solve this. So I'm going to start with the right side because it's easier. If I wanted to write this as a single fraction, I need a common denominator. And so this is 1 over 1. I am going to multiply that 1 over 1 by root 3 over 3 to get a common denominator. And then I get root 3 plus 2 all over root 3 as a single fraction on the right-hand side. I'm going to do the same thing on the left-hand side, but on the left-hand side, I'm going to distribute first. That will give me 2 over the square root of 3 plus 2 square root 3 over 2 square root 3. Again, I'm going to try and get these as a single fraction. Can you see that I could simplify this all the way and make it 1, and it would have even matched to what I had before. But if I want to make this side a single fraction, I'm going to simplify these 2's so my denominators are the same. And then I can add those fractions. I'm going to get 2 plus root 3, which is the same as root 3 plus 2. Therefore, the left side is equal to the right side. We have showed what we wanted to. And we verified it. So verifying it is plugging in numbers and finding out that it works. Verifying is a little frustrating because all it does is tell us, oh good, it works for one value. The proof is the powerful one. Because if you do the proof, what you've said is all the values work. We don't have to verify each individual one at a time. If we can prove it, then it works for 30 degrees, for 45 degrees, for 60 degrees. It works for 27 degrees and even values 13 degrees, not even on our unit circle. It works for everything that's possible. So the reason you have your scrap paper is because you have to do the proof. I'm going to come around. Once you've got it, I'm going to come around and steal your papers, and we're going to see different variations that people have tried. So here's our first proof, our first example. This person, there we go. This person changed the secant to 1 over cos on both sides. They took the 1 over cos and distributed it and got 1 over cos plus 1, which is the same as 1 plus 1 over cos. Left-hand side equals right-hand side. So there's one technique, changing the secant right away to 1 over cos. Here's another example. This person took the secant and multiplied it through first. So secant times 1 is secant, and secant times cos is 1. Now, that matches up as well, and this is another way of doing this proof. Some things to be careful with on here. This part right here, what he wanted to show was he wanted to show that when he multiplied secant by cos, that it's secant times 1 over secant, and they would cancel out. Okay? Having this step here at this point, a couple of things. This line is not equal to this line because he's missing secant times 1. So it would have been better had he shown this is secant theta plus and then showed that this is this times that over that. So because this is work in between from here to here, they would take off a half a mark because the line below doesn't equal the line above. And then it's just scrap work. You're just doing some thinking there, but you wrote it down, and there's no thetas listing here. So there would be an E3 error as well, because your variable missed for a second. Had you not wrote anything down and just gone from this step to this step, they probably would have, well, it would be a little bit dangerous because you haven't shown any work and just wrote down what the other side was. So, some things to be careful in that one. Okay, try the tangent ones. Once you've got your tangent ones, some of the tangent proofs. So here's our first proof. What this person did is they changed all of the cotangents to tangent. So they changed this cotangent to 1 over tan, this cotangent to 1 over tan. At this point, they're saying, I'm dividing by a fraction. Dividing by a fraction is the same as multiplying by the reciprocal. Okay? The fact that they do it in this same line will cause a marked deduction of 1. Because now this is new, right? I can match up that this cotangent is equal to this cotangent's equal to this minus 1 is equal to that minus 1. Where did this come from the line above? It doesn't come from anywhere. You're doing the next step in the same line. So I know that you want to get these questions done quickly, but notation-wise, this line now isn't equal to the line above. So you have to do this, multiply by the reciprocal in the next step. It corrects itself and matches up in the end, but in this line, we've got that mistake because it's not equal to the line above. So when we're doing our proofs, every time we write our next line, it's got to equal what was above it. If something new occurs that's not equal to 1 or not changing, is changing the value of it, then it's going to be a notation error. What's that? Yeah, right. So in this example, same kind of idea. They change this cotangent to 1 over tan minus 1. They change this cotangent, because it's on the bottom, to tangent on the top. So in the second line, everything still matches up with the line above. It's very similar to the last proof, but a little bit different. So instead of changing the cotangent to 1 over tan, they changed the 1 over cotangent to a tan. They then got a common denominator inside by changing the 1 to tan over tan, and then this fraction times this fraction, those tans cancel, and the left side equals the right side. So everything works out here. So both of those examples change things from cotangent to tan. This next example decided what would happen if I changed the tangent to cotangent. So they worked on the left-hand side, changed the tangent to cotangent. It's a little hard to see here, but the 1, they're multiplying the top and bottom by cotangent theta to get a common denominator, and then they get cotangent theta minus 1 over cotangent theta. Now, in this proof, both of these strategies are the best strategies for this one. You look at the equation that you have and changed one side to tangent, so everything was in tangent, or changed one side to cotangent, so everything's in cotangent. It's going to match up nicely because you have the same trig function. One of the strategies that we're going to find, though, is that no matter what trig functions we have to begin with, any of the 6, you can change them all to sine and cos. Because cotangent you can change to cos over sine. Tangent to sine over cos. Secant is 1 over cos, cosecant's 1 over sine, and of course cos and sine are already cos and sine. So one of the strategies that is going to happen a fair bit as we move forward is if you get stuck, you should change everything to sine and cos and see if you can write it as a single fraction. In this example, it's longer and it's messier, but it will work out as well. So this is what that would look like. If I change tangent to sine over cos, and I change cotangent to cos over sine, I've got a lot of fractions. On the left-hand side, I could get a common denominator and write it as a single fraction. I get cos theta minus sine theta over cos theta. On the right-hand side, and I want to point out some things that I did here in my work, I got a common denominator, so I would get a fraction over a fraction. When I'm writing my proof, notice that I put a little bit of space here because I didn't want my fractions to blend into each other. So I start, when I'm working on here, steal something from the line above it. So I leave some space. I also made this main fraction line a little bit longer so that I could recognize, okay, there's the top of my main fraction, there's the bottom of my main fraction. And then once I had a fraction on the top and a fraction on the bottom, well, a fraction divided by a fraction is multiplying by the reciprocal. This cos theta minus sine theta, I put green brackets around, that gets grouped together as one factor. But we have factors that are identical. Those signs will cancel out. And we're left with the exact thing on the other side. Probably the shortest proof that I can think of for this one cotangent theta minus 1. Okay? I'm going to take this whole side and multiply by, change it to black so you can see it better. I can take that whole side and multiply it by cotangent theta over cotangent theta. That's allowed because what am I multiplying by? What is cotangent divided by cotangent equal to? 1. And anytime you multiply by 1, you're not changing what it's equal to. Now when I multiply this, because this would be over 1, can you see that I would get a cotangent on the bottom? And cotangent times 1 is cotangent. And cotangent times tangent is 1. And that also solves it in one step. So there's many different proofs that you can use for the same one. Okay, the questions for practice, but we're not going to do them right now. 3, 5, 6, and 7, II.